Here we have an example that will use Newton's method to approximate the solution to an equation. Here we're asked to find, correct to 6 decimal places, the solution to the equation cosine x is equal to x. Now, a couple of things to notice. Here they don't give us a starting point. There's no x of 1 given. Also, the structure of the problem is slightly different. Instead of saying here's a function f of x, find where it's equal to 0, you're given an equation. Now we can easily take one of these problems and turn it into a similar problem to the one we have already seen. In particular, we'll take cosine x equal to x and move everything to one side. Doesn't matter if it's all to the left or all to the right, but we'll take this x here and move it over to the left and consider working with cosine x minus x equal to 0. I'm going to call this expression f of x. So let f of x equal to cosine x minus x. So if I can find for you an x value that will make f of x equal to 0, then I have found for you the x value that is a solution to this equation. So we'll just apply Newton's method to this function. Now again, in this case, we don't have an x of 1, so we have to make a reasonable guess of what to select for our starting point. If we graph out our function cosine x minus x, we'll see that it does have a 0 around maybe 0.6 and 0.8. In this case, let's say that we start off with a initial value of 0.8. So let x of 1 equal to 0.8, and let's see what happens. When computing our x of 2, this will be equal to x of 1 minus f of x1 divided by f prime at x1. And in this case, our f prime of x is equal to negative sine x minus 1. So x2 would be 0.8 minus cosine of 0.8 minus 0.8 divided by negative sine of 0.8 minus 1. And this is approximately given as 0.7398533.064. I can continue the process to get my other iterations, and if I compute my x of 3, I get approximately 0.7390852.634. In this case, between x of 2 and x of 3, the first 3 decimal places are in sync, but the others are not. That lets me know that I should go a little further to get a better approximation. If I continue this process for x of 4, I get approximately 0.7390851.332. In this case, if I can make comparison between x of 3 and x of 4, I see that the first 6 decimal places are in sync. Just for kicks, let me continue doing this and see what I get. X of 5 will be 0.7390851.332. Notice at this point, the values of x of 4 and x of 5 have repeated, and if I compute any values thereafter, I'm still going to get the same value. So I feel fairly confident that I have the first 6 decimal places nailed down solidly. as 0.73908. 5.